Okay, let's add some code to this spaceship then, so we can control it just as you would in the game of Asteroids. And to do that, we're going to make use of Unity's 2D physics system. It does work fairly similar to the 3D, but there's a few little bits to note. So, to get set up first, I'm going to select the spaceship. If things are getting a little bit awkward and it's proving difficult to select stuff, you might want to move this quad away. So you could actually jump to 3D and just drag it away. You can see it was tearing in to the sprite there. So let's just pull it back. It's not going to affect the view finally, because you can see when we go back to 2D it looks exactly the same anyway. But hopefully it makes it a bit easier to click on the spaceship. With it selected, I'm going to add two components. We need, similar to the 3D here, when we were working in 3D, we had a rigid body and some form of collider. 2D follows suit. We do need a rigid body and we need some sort of collider again, but the options are slightly different. We could put a straight up circle collider on there. We could scale it down a little bit, that would be okay, but it's not quite accurate, so I'm going to get rid of that. And instead I'm going to add a polygon collider. And if you click that, Unity will have quite a good go at making a shape around the content of that image. So it's not done a terrible job, but let's refine it slightly. So we can edit it using this Edit Collider button. Click that, and the options when you're hovering around the collider will change. We get this green dot, so we can click and drag to add points if we ever need to. Don't think I need a point there. So instead I'm just going to move the existing ones just to better match the outline of this ship. If you do need to get rid of any, you can hold the control key. So I could hold control and I could click and that point would go and it would just stitch the other two together. But I don't need to do that in this case. And just bear in mind when you're doing this, in general, it's better to be forgiving to the player. You want to be on their team rather than make it like this, for example. If this gap here ever killed a player, they'd be outraged. Whereas if, for whatever reason, we had it like this and we got something came there that probably should have killed them, but they survived, they'll be okay with that. They'll think their skill made them live, and that's fine. But if they die when they shouldn't, they're going to get annoyed. So just something to bear in mind. I think I do need a point here, so let's add one in. Drag that one in and let's put that there. So we can very closely match the shape of a 2D object, and that's much better now, so we'll leave it at that. I'm going to zoom out a bit and I'm going to add another component. This time in 2D physics I'm going to add a rigid body 2D. And let's just hit play at that point. So you can see there that when we hit play the spaceship drops down. That's because it's got a rigid body on and the 2D physics system is applying gravity to it, just as you would probably expect. What we could do in 3D was just simply tick a box that stopped gravity working, but the 2D system works slightly differently. We've got this gravity scale instead, which is just how strong the gravity is applied to this rigid body. So we can actually drop that down to something like 0.2, which would give us 20% gravity, and hit play. And notice that the ship drops much slower. But we want to get rid of that altogether, so I'm going to put that to 0. In the Asteroids game that we all know and love, there is no gravity. There's just a spaceship and then your own thrust. So we're set up for that now, and we'll add the thruster code to make it move. So we're going to start by adding a script. I've already made a folder for this. So in a scripts folder, let's just right click, create new C# script, and we'll call that player controller. And once it's created, let's just load it up. I've got the old version there that I actually broke because I'm a bit thick, so let's not save that. Okay, so in the real one, we want to store our rigid body straight away. So let's make a private variable here, just as we did in 3D. Private rigid body 2D, call it RB, and then in the start function we'll do RB equals get component rigid body 2D. So there we go, we've grabbed hold of the rigid body and we've stored it. Let's get rid of this comment as well, and if you remember back a few videos, I did say that update is possibly not the best function to use when you're working with physics. There's the update function that happens every tick of the render, I suppose you could call it. But there's the fixed update, which happens every time the physics engine updates. So I'm going to use fixed update instead to apply any forces to this rigid body. And in there, just going to do rb dot add force, and then in brackets we actually need to apply the force. So let's just have a quick look at Unity, and you can see here that the spaceship, when we're in move mode, is looking up the y-axis. I did point that out before, but we just need to make sure we're working in the right direction. So we don't want to add any force this way. In the x-axis we want to apply it going up, and to cut out the middleman there, instead of making a new vector, we can just use the up part of our transform. So we can do transform dot up, and that will give us that direction. And then we can multiply that by our input. So we can do multiply by input dot get axis, and in brackets there we want the vertical axis. And there's a house alarm going off behind me. Hopefully you can't see it, hear that. We're going to add force in the up direction using the vertical axis of our control. So let's just save that and give it a try. And it would help if I actually put the component on the spaceship, wouldn't it? Getting distracted by alarms. Select the spaceship, let's put the script on and hit play. And we're off, albeit very slow. So that's not too great. Let's apply a bit more force to that. So as well as multiplying by the actual input, let's multiply by a variable that we can adjust from in Unity. So I'm going to make a variable called power, and then up at the top I'm going to make a public float called power, and let's have a default of maybe 3f. So we've multiplied our input by the power and we've saved it, and then we try it again, and that's a bit better. It's possibly a bit too slow, but you can now play around with it straight away in the inspector here. So still can't click on that thing. We can change the number here up to maybe 5. 5 seems like it might be the sweet spot. That's a bit nicer. Yeah, okay, so I can live with that. And now the next step is to do the rotation. So we're not going to move side to side using the arrow keys. We're actually going to rotate instead. And I'm just going to apply that before the transform. So here I'm going to do transform dot rotate. And in this case, we want to just very quickly rotate around the z-axis. So we want to pivot around this blue line. But it's worth noting the way that this actually goes. So with the object selected, if we watch what happens when I increase this z rotation, so I'm adding to the rotation, notice the spaceship's going left. So it's just worth bearing in mind that positive rotation actually goes anti-clockwise, which seems a bit wrong to me, but we've got to deal with it. So I'm going to put that back to 0. And in this rotation, we don't want any x rotation, we don't want any y, and then we want to use a negative version of our horizontal input. So we're going to put minus input dot get axis horizontal. And make sure all the brackets are closed. And we might need to multiply that as well. So let's just see how that's going. If we save it up, try it out, we can now rotate, and yes, that's very slow. So let's have a similar process to the thrust where we have a rotation power. So let's do multiply by rotation power and make that variable up here. So we'll have public float rotation power equals, I think that's probably going to work out quite well being the same as the thrust, but we'll do a default of 3 again. And you can play around with it to get the desired effect, but that's much nicer. And because our movement is based on the direction we're facing, we've now got this effect. Probably going to be lost now. Yeah, gone off screen forever. So the movement is pretty much sorted with 2 lines of code there, just owing to Unity's very nice physics system and general setup anyway. So that works really well with 2 lines of code-ish. But we're getting lost when we go off the screen, and that doesn't happen in Asteroids. So let's make another component. We're going to do it in a separate component now because we're actually going to reuse this across multiple game objects. So it's quite nice to have it separate, and we can just put the same component onto our asteroid objects so that they behave the same. So I'm going to right click in the scripts, and I'm going to create another C# script called movement wrap, or screen wrap, whatever you want to call it. Just make sure the name makes sense, and let's open that up. And in here we're going to use it to just make sure that when you go off the top of the screen you respawn at the bottom, and so on. So we don't need the start stuff, and I'm actually going to hard code a lot of the numbers in as well, so you might want to adjust it slightly where you can edit it from outside, but I'm just going to hard code the numbers for the sake of this particular game. And again, I'm going to use the fixed update. It might as well follow suit with the physics stuff. And in there, we want to know when we've gone above a certain position. So let's have a quick look. We've got the ship. At the moment, its Y position is at 0, and if we drag it up here until it's gone off screen there, you can see that that's around the 4 mark in the Y-axis. So it's gone 4 units up, and it's now off screen. I think we'll put a bit of give in there just to make sure it's fully off screen when we come to do asteroids, which might be a little bit bigger than this spaceship. So let's reset that, and we'll go to maybe 4.5. So in the code, I'm going to put if brackets transform dot position dot y is less than minus 4.5f. So there we go. If the y position of this object is less than minus 4.5, then something. And this is where we'd put the something. So it would be very nice if we could just put transform.position.y equals 4.5 instead. That's the logic. We want to just drop it to the other side of the screen. But as we noticed in the first set of videos, we can't do this. We can't directly affect the y position like that, as nice as it would be. So we're going to have an interim variable that we store at the top. So just here, I'm going to make a vector3 called pos for position, and it's going to just basically copy our current transform.position, not broadcast message, transform.position. So we're going to store that in a temporary variable as it suggests when we get the error, and then here now we can use pos.y. And notice there's no curly brackets in my if this time, and it's because there's only one thing to do. So just asking a question and instantly doing something. We're not going to have the curly brackets to wrap a lot of lines because there's not much to wrap. Then we're going to copy this and do the same for going off the bottom. So if the y position is greater than, oh sorry, I've got this the wrong way around, that is off the bottom. So the bottom is negative, sorry, my bad. If we click on the spaceship and drop down, you can see that's negative. So down there, minus 4.5 is there. So got those back to front. But the code's not going to change. So this time, when we've gone off the top of the screen, when the y position is greater than 4.5, we want to set it to minus 4.5. And then the last step down at the bottom here is to just put this temporary variable back into our transform.position. So we do transform.position equals pos. And there we go. So we've stored it temporarily, we've amended it, and then we're passing it back in. Make sure it's saved up, and let's see what happens when this time we actually will put the script on. So put the movement wrap onto the spaceship and give it a go. And we move up and we appear back at the bottom, and we're actually forever accelerating because of this code. So that works. Let's should maybe restart it and give it a go the other way. But I was nearly slowed down enough there. And if we go off the bottom, come back on the top. So that's all good. Now let's apply it to the sides as well. So the sides are very similar, except we're working with x. So let's copy that and let's find a suitable x number. So I'm going to paste them in and then drag the spaceship off the screen. So we want to be about there, which is 7, an x of 7. So again, I'm going to add a little bit to it, maybe 7.5, we'll use, and we'll go from there. So if the position X is less than 7.5, we want to change the position X to be 7.5. And then let's just quickly amend the other line, so it's 7 and X instead of 4 and Y. Make sure you do swap them all, you don't want to be changing the X position to be the Y position and what have you. Save it up, give it a try, and you should be able to rotate and go off the side. And we can that way, and let's just spin around and go back the other way. And we can now go off each side of the screen and reappear where we should. So that's pretty cool. And that is very basic 2D physics. We are going to do some collisions and various other bits in the upcoming videos, but I think we'll leave that one there.